Hi everyone, welcome back. Let's see one of the system called fork system call. Guys, fork system call generally used for to create a duplicate process. Generally, if I say a system calls are meant for to serve various kind of services to the end user that we have seen in the earlier video. Now, in this video, we are specifically concentrating on one of the system called in-depth because it is very useful for to solve various kind of gate questions. And in the previous years also, almost all the questions are on the basis of fork only in the first unit, right? That's why you have taken the specific video for this, right? So, if I say there is a process P1 which contains a set of logic and there will be a kind of fork system call also. Fork system also means while executing this set of lines of code, it will encounter definitely fork system call. So when it encounters the fork system call, it will create a duplicate process of the same process. What are the meaning of this one? This entire code is going to be duplicated again. Is going to be duplicated. Now it will look like this. If you observe clearly in this particular explanation, now this fork will be available in which process? Parent process, because it is the main process, and this fork is, I can call it as a child process fork, and this will be the parent process fork. Why I am calling this a child process fork? Because it was created by some other process. So I can say that which is used for to create, a process, that are a part of themselves. I can call it as a fork, guys. Okay, so let's dive into the examples so that you will get clear idea. For example, void main. I'm trying to write some certain C program where I am trying to perform printf functionality with thank you, and I am trying to execute this one. When I am going to execute this one, what might be the expected output, guys? Simply thank you, because it is executing in the user mode, because it doesn't have any kind of privileged instructions. It will directly execute it. There is no problem. We can expect the output as thank you. For example, if I modify the code in such a way that void main, I have a method called fork method followed by printf thank you. Now, can you just pause the video and guess the output? How many times your thank you will be printed? Here, thank you is going to be printed for 2 times, guys. How sir means? You can get this idea. Observe. It is because of existence of the fork. So, as of now, P1 is a kind of a process. Which is executing until here. Once executes the P1 process, once it executes the previous process, as it continues the fork, it will create what? It will create another process. What are available so far in the CPU, right? So far in the CPU, I have P1, so it will create a dummy P2. So that's the reason we have 2 processes now. Process P1 starts its execution and process P2 starts its execution, right? So what might be the code here? Fork will be there and printf will be there. What might be the code in P2 process, fork will be there and printf will be there. You might get question. From which level it is going to start the execution? From the next line onwards, it is going to start its execution. I mean, once the fork system call executed, immediately it is going to create the duplicate process and it is going to start executing from the next instruction onwards. Right? So as this fork in the parent process is executed, printf is going to be executed. That's why you got the thank you. And this is already executed in the parent process. That's why this printf is going to be executed. That's why you got one more thank you. Right? Sir, you might get question. Sir, is both are executing parallelly? It might not, or it may be. Either P1 execute first, then P2, or P2 executes first, then P1. It can happen in any of the way according to the CPU scheduling algorithms. That CPU scheduling algorithms will look into further videos. Right? Okay, fine. I hope you guessed you understood this particular example. Number 2. This one will be 1. Let me take one more example so that you will get a clear idea. Void main. I have one system call fork system call, another system call fork system call, and I am trying to perform printf thank you. Then what might be the output guys here? Just do the process like this and tell me the output. Yes. Your output will be 4 times of thank you. How means? If you are able to observe, right now process P1 is executing. Process P1 is executing. At that situation, it got a fork method. It got a fork method. When it got the fork method, what it is going to do? So far, whatever the process are there, for all those processes, it is going to create a duplicate process. So far, we have only P1 process, so it is going to create a duplicate process for it. Let's put P2 done. Next, it is going to execute the next line of instruction 4. So once it encountered 4, it is going to create the duplicate process. For what it is going to create the duplicate process? So far, whatever the process that are available in the CPU, for them it is going to create a duplicate process. So P1 is available already. Yes. So for P1, it is going to create duplicate process. For P1, the duplicate process something like P3. For P2, it is going to create the duplicate process something like P4. Done. Yes. Next, printf statement is going to be executed, right? Which means that how many processes are there so far? So total you have 4 processes. I am trying to write the logic clearly here. So here fork printf, fork printf, fork printf, fork printf. Guys, just observe the things how it is working, and at the end of the video you can be able to clearly understand how it is working. Okay, so now observe, for this fork we come across with the P2, and then it is done with execution and it is no need to execute because it is child fork, and next line immediately it is going to start executing this fork. For this fork, this is done, this is created, and for this fork it was created. Then you already know this was done by parent process P1, this was just now done by parent process of the second fork call, and then it is going to execute this printf statement. Similarly, here also this was done by parent process P1, this was done by parent process P2, and it has to execute this one. So now, how many times the printf statement is going to execute it? Here the printf, here the printf, here the printf, here the printf. So total 4 times of thank you will be executed. And here you might get one question, the general question. How many number of total processes are there in this particular example number 3? How many number of total processes are there, guys? 4 total processes are there. How many child process, or I can say how many new processes created. How many new processes created? Total 3. Why 3? P1 is already a process which is running. Once it encounters fork, it is trying to create P2, P3 and P4. So total processes are 4 and total new processes are 3. Right? If you look into the same question here, total processes are how many? Total processes are 4. Among those 4, total new processes are what? Sorry. Total processes are here 3. Sorry, 2. Total processes are 2. How many new processes are here? 1. Right? What about here? Total processes are 1. Is there any new process? Or I can call, is there any child process? No, 0. Like that we can able to do. Right? So let's take one more example so that you can get clear idea. So let's take the fourth one. Void main. I will try to take fork is system call. Fork is system call. Fork is system call, and I am trying to perform printf. Once again, thank you for watching the video. Like, thank you. Right now, guess the answer directly. What are the total number of processes? How many child processes are there? Right? If you look into this particular earlier slide, here total processes are 4 as it is having 2 forks. Here total processes are 2 as it is having 1 fork. Right? Which I can say in general, if I am having 3 forks, I can have 8 total processes. And then 7 child processes. Means if I am going to have n fork system calls, I can have 2 power n total number of processes at the operating system level, at the CPU, and 2 power n minus 1 system calls. Based on that, I can say this one. Right? Then how this printf is going to be executed? Printf, how many times the printf is going to be executed? You can make it in the comment section, guys. Okay. If you observe clearly, fork is a kind of system call, right? Means I can say that it is a kind of a predefined method, right? The predefined method generally processed by the operating system, and it will return certain set of values. Those set of values are either it will be a negative value, or it will be a 0, or it will be a positive value, guys. I mean, fork is a system call which will return 3 types of values: negative, 0 and a positive value. When you are going to get negative value means when it is unable to create a duplicate process, then you are going to get the negative value, right? I mean, what might be the chance of not creating the process? When there may be an insufficient memory. When there might be insufficient memory, at the situation, fork method may not able to create the process, and it is going to return the 0 when the process will be a child process, and it is going to return some number. Generally that number we can call it as process ID, guys. Process ID, which means a positive number. So in general, in the CPU, let me take a CPU. This CPU having many processes, process P1, process P2 and so on, right? If I want to identify a particular process uniquely, I have to give certain unique number or not? Certain unique number. That unique number we call it as process ID. That process ID is going to be written by this fork system call, right? So what is the general meaning of it here is, for example, if I take something like this, let me take the C program, void main, and if I say id equal to some fork, and if id double equal to 0, I want to perform printf thank you, else printf something like subscribe, right? Now it's a kind of a simple program. Generally how it is going to be executed, you know, this is an execution done by process P1. While executing the process P1, fork system call is encountered. When fork system call is encountered, it is going to create the duplicate process of the same process. Then what made the code existed here again? The code will be the same code, id equal to fork, and if id double equal to 0, some case, else some case. Similarly, the same code is going to be executed, id equal to fork, if id double equal to 0, some case, else some case. Now understood guys? Understood? P1 process is executing, assume P1 is first executing, then P2, I am assuming, right? As P1 is executing, is this fork method is executed or not? Because of execution, P2 is created. Now it will return what value? It will return a positive number. It is because of it has created the process P2. So here we are going to get a positive value. Then if it is going to get the positive value, is that positive value is equal to 0? No. When it is not the case, it is going to produce output as subscribe. So answer will be subscribe. That will be done by the process P1. Then once P1 is completed its task, P2 will execute. What about here the fork? Is it going to be created again? No, which was already done by the parent process. So it is going to return the value as 0. Why it is going to return the 0? Because if it is a child process, it is going to return the value as 0. So it will return the value as 0. Is id double equal to 0? Yes. When id double equal to 0, it is going to print thank you. So answer will be subscribe and thank you. Right? So like this, you can able to execute the particular fork system call. Right? So to make it more clarity, in further videos, I am trying to take various kind of gate questions so that you can get more idea and you can able to solve any kind of gate question. Hope you understood this video clearly guys. Thank you.